Welcome back, 7th grade. So good to have you. Today I want to teach you how to tell if a sample is representative of a population or not. So please make this the title on the next free page in your math notebook. And then mark that page with your pen or pencil, close it up, and give me your full concentration. A couple things to go back over real quick before we get started. So in 6th grade, hopefully in your statistics class, you learn to look at a set of data and talk about its shape, center, and spread. I'll start at the back. So spread, we generally are talking about things like range, like how spread out the data is, right? So this, technically has a spread from 4 to 11. You talked about center. Center is talking about things like its mean, median, and mode. Those are measures of center. And with graphs, sometimes certain ones are easier than others to find. Like mean's not very evident. Median you can find out kind of easily on a graph. You just count how many of these there are and then find the one that's in the middle. Like I'm guessing it might be that one. I didn't count. Mode is super easy to identify. So sometimes you do these things with a graph, talk about their median and their mode without doing a lot of specific calculating. It's more of like a general thing. And then shape too, we just kind of look literally like how's the data shaped. So this one's kind of shaped in a way where there's not many data points early. And then there's a big cluster, we would call this, from 8, 9, and 10, like a close set of numbers that have a lot of data toward the end. So it kind of has like a tail, a bell, maybe you call it something like that. And like a big cluster here or something. So just generally looking at how the data is shaped. It's not a real formal thing. It's not like here's the right way and the wrong way to do it. It's just noticing kind of some pattern in how it works. Other things, we talked yesterday about population sample and representative sample. So like if this is, I think this was supposed to be the age of seeing some movie sample. So population would be like everybody who saw the movie. And it's often hard to ask, like, how old are people who want to see this movie? It's hard to ask everybody because if millions of people see a movie, you can't ask everybody, but that's what that means. So we often just ask a sample of people, which is a smaller group. And we hope that the smaller group kind of tells us what we know. So this may have been a sample, like, okay, this looks like about maybe 15 people. We'll just ask 15 people who saw the movie. How old are they? And that might give us the information we need. And then last but not least, we talked about a representative sample. And that means that your sample needs to represent everybody, represent the population. So like this sample probably didn't, because I don't know what movie only people under 11 can possibly go see, because usually like a parent would be with them or something. So I think there's kind of no way, if I look at that this is representative of everybody who saw the movie. So representative samples just have to do that. So I want to like analyze some samples today. So let's look at this one here. So the price of a pound of catfish at a market was recorded for 100 weeks. That's a long time. That's our population, all the weeks. And so if we want to, here's the how it looked. So all 100 weeks are on that chart. Here is the price per pound of catfish. So it looks like it was as low as $1.60 per pound, as high as $2.80 per pound, and a lot in between. So that's our population. And again, populations are difficult to deal with. They're so big that often you can't do this, or you don't want to do this, ask the whole population, or like look at this 100 times. So you say, okay, well, let's just pick a smaller number of weeks and hope that that represents the population, gives us the same idea. So I'm going to slide over a new question. So here it is. So if the goal is to have the sample represent population, which of these, this one, or this one, would best work? Which sample does it look like represents all 100 weeks the best? They each have, it looks to me like maybe about 20 weeks instead of the whole 100. That makes them a sample. But some of these samples are better representative of the whole population than others. So I want to look at them for things like shape, center, and spread. You're going to notice I'm not going to do a whole lot of calculating, but I am going to think about these three things. Do the shape, the center, and the spread of the sample roughly match the population? That's what I'm aiming to do. So let's analyze these one by one. So my population has a general shape like this. Like it has a huge spike at the beginning. So a lot of the weeks had a pretty low price. And then it kind of levels off from there. You'll notice I'm being general. I'm not following like every curve, but it looks like we had a big spike over here, then some sort of like gradual up and down, but not a big variation from there. So as I look at these samples, like in terms of shape, this top one looks pretty good compared to the population, right? We still have that big spike at the beginning. It's not as big because it's a smaller group. And then we have a little bit of up and down all the way out from there. So that shape is pretty good. So I'm going to give that kind of like a red check for the first thing. Sample 2 has the big spike at the beginning, but then there's nothing above 2 weeks. There's nothing out there. So its shape just kind of looks like that. And there was lots of weeks that had more than $2 price. So that's not, in terms of shape, in terms of shape, that one's not very good. So I'm going to give it kind of a no on shape. Same here. This one doesn't have a similar shape to the population. There's no big spike at the beginning. And there's lots at the end without the spike at the beginning. Not very good in terms of shape. So the top sample by far, in terms of shape, most accurately represents it. How about spread? I'll do spread in green. So our spread in our population is from about $1.60 to about $2.80. How about here? Sample 1, exact same spread. That's really nice. It goes from $1.60 to $2.80. So great in terms of spread. Sample 2 has a tiny spread. 160 is the lowest price, 2 is the top price. It's nowhere close in terms of spread to the population. Not a good sample. Sample 3, the spread is pretty good. We don't have any $60s, but there weren't really many $60s in the population, so that's likely to happen. And we go from 180 to 280. That's pretty close in terms of spread. I like that one. Last but not least is center. I spend the least time on this, but you're going to see why. So in terms of center, I'm not going to sit here and try to calculate the mean, the median, and the mode. I don't think that's necessary to tell if they have a similar spread. What I do want to do is roughly see, is the mode close, not necessarily exact, and can I tell, like, is where roughly half the data is on each side? Like, I'm eyeballing it. To me, it looks like somewhere around here is probably about 50 over there and 50 over there. I'm just eyeballing my median. I'm not calculating it. You could. I just don't want to. So that's what I'm looking. So here my mode is, $1.80 and $1.70 both had a lot. $1.80 is technically the mode, but they both had a bunch. So here, boom, exactly. My mode matches perfectly. So that's good. And again, it looks like to me about half of them are there, half of them are there. Roughly the same spot in the middle of the graph. So that one's a great match on all three. Sample 2, the medians the modes are a great match. They match perfectly where the mode of the population was, but the median's not. Like the median's probably around here. Like half are below about 175 and half are more. So the median, the middle of the data, nowhere close on that. Mode was though. And last but not least, down here, I don't really match on mode. I have a mode here and I have a mode here. That's nowhere close to what happened in the sample. And it looks like half my data is like all the way over at like 245 or something. So not a good match there. So here, sample 1 was by far the best sample because it matched pretty well the population in shape, center, and spread. All right, open your math notebook. If you're in my class, you do not need to write this down. I'm going to just give you this tomorrow. So you don't have to do all this work. I'm sorry if you're not and you are, keeping track of good notes. Either screenshot this and print it or go ahead and write it in your math notebook now, and we'll analyze and see how well these 3 samples did for showing this population. Okay. So this shows the scores on some video game of a lot of teenagers who were asked the question. So this is our population. And however this game works, the lowest score was 40, 200 in between. So we're going to look at this in terms of similar shape, similar center, and similar spread. How does that work out? So let's start with shape. I would say this population had a pretty even shape. Like pretty much there's 1 or 2 people at almost all the scores. It does have a small cluster. It doesn't go super high, but a small cluster right in the middle. But it's generally pretty even. Like there's roughly, 1, 2, 3, 4 people getting every single score. So I would say it has a pretty even shape. So when I look at these, and it's even all across. So here I kind of see an all right even shape. Here I see kind of an all right even shape. Here I see kind of an all right even shape. So I would say none of these are terrible in terms of the shape. None of them are great. None of them look really like it in shape. Like none of them have the small cluster in the middle. So shape, I think they're all kind of okay. I don't think any are great. So let's talk about spread next. Spread's kind of an easy one to see, right? So when I look at the actual group, they spread from 40 to 200, so they had a very wide spread. You'll notice again, none of the samples have an exactly the same spread, but sample 1 has a fairly reasonable estimate. It goes from 70 to about 195. It is the most spread out, and this was very spread out. These are all super clustered in one place, very high scores or very low scores. So in terms of spread, rather, I really think only sample number 1 is reasonable in terms of center. In terms of spread, I'm so sorry. So what about center now, which I keep saying? So we look for the center. Remember, we're just kind of eyeballing the median and the mode. The mean is not easy to estimate from graphs. So let's just look at the median, the mode and the median. So the median, or the mode's obviously 130. None of them have anything like that. So that's not really something we can tell from any of our samples that the mode would be in this middle range around 130. Median, so now we're kind of eyeballing where's about half and half of the people. So this is, I don't know how many, maybe 50 people, 40 people. I would say about half of them look to be below, say, 115 and half above-ish. Again, you'll notice I'm not counting, though I could. If you want to be really precise, you can. But since my samples aren't going to be perfect anyway, I think just being close is fine. So it looks like to me somewhere around 110, 120 is the median. Down here, half and half, probably about here, around 130. Here the middle's like way up at like 175 probably, like really bad. And here the halfway point's like right here, probably around 75. So not even close on the bottom 2. So I think the top one is by far the best sample. It's the best on all 3 measures. Y'all, I hope this helps you look at a sample on a line plot and tell whether or not it is a good representation of the entire population. If not, please go give this a second look. I promise it'll help. And other than that, I can't wait to see you tomorrow.